Hi guys, welcome. So I don't know if I told you, but I am not here today. I'm leaving this video for you guys on the next lesson, so lesson 17. Um, I forgot my little tool that I use to record these videos, like to write with, my little pad. Um, so I'm going to be writing with a mouse, so bear with me. Sorry if my handwriting is worse than it normally is. This video is going to be uploaded to student view, so you can watch it later if you need to rewatch it or if you missed something. But I would say during class, just follow along the best that you can. Keep up with the notes, keep up with the video. You should have time at the end of the video to get started on your assignment. But again, if you need to go back and rewatch the video to get a better understanding or just to, hear me again, you're welcome to do that. So just log into Student View, click on the gradebook, click on Honors Geometry, and then Lesson 17 will have it attached in the resources. So today you will not need a compass or a protractor. You're just going to need a pencil, colored pens, notes, assignment. They should all be where they normally are. Your essential question for this set of notes is which angle is needed to satisfy SAS congruence criteria in two triangles? Today, I'm going to just leave the date off because it could be Tuesday, it could be Wednesday, depending on what day you're watching this. So I'll just let you fill in the date. So far what we have been working on is constructing congruent shapes. So you guys have been constructing triangles after reflections or rotations or translations. We have been emphasizing the fact that the resulting image should be the same size and the same shape as the original one. So now we're going to shift gears and say, if I were to look at two triangles or if I were to look at two shapes, how could I justify that they're congruent without having to do all of those transformations? So today we're going to show that there's a criteria that refer to a few parts of two triangles and correspondence between them that guarantee congruency. So again, I've said this before, I'm going to start using this term a lot, congruence, congruent, congruency. That really just means that they are the same size, the same shape. So we're going to start with side angle side or SAS criteria. So this is the introduction to what SAS is. Given two triangles, ABC and A prime, B prime, C prime, so that we've got this image here. In order for SAS congruence criteria to work, we want to look to see that both triangles have the same pairs of sides that are congruent and that the angle between both of those sides or the angle formed by those two sides are also congruent. Just knowing those pieces of information is enough for me to justify that these two triangles are exactly the same size. So I don't necessarily need to know that BC is the same size as this B prime C prime. I don't need to know anything about angle B being congruent to angle B. Nothing. All I need to know is that it's got two sides that are the same and the angle between them is also the same size. So when identifying this, I would see, well, for the sides, they have this AB that is congruent to this A prime, B prime, and I know that because they both have one little tick mark through them, or one little dashed line, however you want to think of it. So one side that they share is AB is congruent to A prime, B prime on the other triangle. Again, sorry for my handwriting, I'm using a mouse, this is horrible. Next, I usually go and identify the next side. So the next side that they have in common is this AC. Notice it has two little tick marks. A prime, C prime also has two little tick marks. So my next thing would be that AC is congruent to A prime, C prime. And then finally, the last thing I look at is the angle. So I look to see if the angle that they have in common is in fact the angle that's formed by the two sides that I highlighted. So yes, in this case, I'm going to say angle A is congruent to angle A prime because they were both already labeled and they are both the angles between the two sides. So notice SAS, the A is in the middle, or the angle's in the middle, because it's between the two sides that form that angle. That's really, really important for SAS because we will talk about 4 more triangle congruencies later on. I think we finish off the semester with triangle congruence. So There are 4 other ones, but we start with just SAS because it's one of the easier ones to identify. So to justify why this works, we're going to think back on constructions and how I could prove that these 2 triangles could map onto each other just knowing the given information. We know, of course, if they map onto each other, then they would be congruent, because mapping onto each other means that they overlap each other. So they should overlap perfectly, and I'm going to justify that here. So by our definition of congruence, we have to find a composition of rigid motions that maps the primes onto the pre-image. So we're going to do that here. We must find a congruence F. Sorry, let me delete this. You don't have that on your paper. So we must find a congruence F so that the F, or that transformation, whatever I do, to A prime, B prime, C prime actually results in ABC. So first we're going to use the translation T to map to a common vertex, or to map a common vertex. So looking at these 2 triangles, we know for sure that this angle A is congruent to A prime. So I'm going to draw a vector that joins those 2 angles together. So I'm going to say, let's draw the vector from A prime over to A. And a vector is kind of like a ray, but it's just half of an arrow. So I think of a vector as just part of an arrow. So if I were to draw that vector, I would say going from A prime to A. If I move those together, I know that those 2 angles correspond to each other because they're the same size. That was given to me. So can other pair of points be used? And I'm just going to type out this answer because it's difficult to write. In this case, I would say no. No other pairs of angles could be used because I don't know anything about B being equal to B prime at all. The only one I know for sure is that the A and the A prime are congruent to each other. So here I would say no, because I do not know if angle B and angle B prime are congruent. I also do not know if angle C and angle C prime are congruent. Therefore, I can only use angle A and A prime. Angles A and A prime. Okay. So I'll give you a minute to write that. Again, if you need to go back and rewatch this so that you can write it, I will have that video uploaded. I'll also have just the notes uploaded so you can look at either one, whatever's easier for you. So in this case, no, I cannot do any other sides. I would just have to stick with the ones that I know map onto each other perfectly. So the next part, after the translation, we can see that if I were to slide this triangle up, I should end up with this image. So the triangle was here, I slid it up. Now notice that the A prime ends up overlapping where the A was. So I'm just gonna leave that A there and get rid of the prime. But since it was B prime earlier and now it's B double prime, that happened because I translated, or I moved that shape. So remember when you were doing lesson 16 and you were doing a composition of transformations, you took the primes and then reflected them, for example, and they became double primes. And then you took those double primes and then rotated, those became triple primes. That's really what we're doing here. So it says, after the translation below, remember that this just means that you're doing a translation. So translation from A prime to A of the triangle A prime, B prime, C prime. So we did the translation to this triangle. Now it shares a vertex A. So now we can really say that the triangle, or the transformation of, and I'm going to type this out too because I think that's easier. The transformation of triangle A prime, B prime, C prime really became triangle A, B double prime, C double prime. And so again, you can see that here, that this triangle was here as primes. It shifted up. The A took the name of the A that was already there, and then the B and C became double primes. So after that, we're really, again, our goal is to map this triangle onto the pre-image. We're trying to see if they overlap exactly and map onto each other. So next we're going to use a clockwise rotation. And so notice I had you not get your protractor out today, and that's because I wanted you to see that we can just say to do a rotation given a specific angle. So if I'm trying to rotate these so that this side maps onto the corresponding side, because I know they're the same length, right? I could do a clockwise rotation going this way of that angle C double prime A to C, or I could call it CAC double prime, right? So I'm going to say clockwise rotation of angle CAC double prime. And if I do that rotation, I'm going to end up closing this gap, or I'll close that angle. So it'll bring the side AC double prime to the side AC. Or I could think of it as doing a counterclockwise rotation, which would just be in the other direction. So if I did this counterclockwise, then it would just do the reverse. It would bring AC to AC double prime. Either way, we're trying to just close that gap there to say, well, I know those are the same size, so I can map them onto each other directly with this rotation. So after we do that rotation, you can see the little arrow drawn here, we should end up with this resulting shape. So it says after the rotation, and we can say of that angle CAC double prime, a total of 2 vertices are shared with triangle ABC. So now we see that when we close that gap, this angle A was already overlapping, but now this angle C double prime is overlapping the C. So it shares those 2 vertices A and C. Therefore, that rotation, we did the rotation on this triangle A, B double prime, C double prime. So we did the rotation to that, but our resulting image was now this A, let me scroll down a little bit. Our resulting image is A, B triple prime, and C, because we took the name of the C that was already there. So we'll type that in. My resulting image is A, B triple prime, C. So we're almost there. We've almost got these mapped directly onto each other. Finally, if B triple prime and B are on opposite sides, like you see here, of the line that joins AC, then a reflection across AC will bring that B triple prime to the same side as B. A way to visually confirm this is to draw the marks of the reflection construction. Or you can think of the perpendicular bisector construction. So really the way that I imagine it is if I were to connect B to B prime, right, then you should see that this is perpendicular. It should form a 90-degree angle, so that justifies to you that these will map onto each other. Another thing that justifies it, the bisector part, you should notice that this length from, maybe I'll put 3 marks through it, from this intersection to B, that length is the same length as this side. So that's what I mean by perpendicular bisector construction. Or you can do the reflection like you normally would. So if I were to take my compass, extend it past the line and draw my arcs, and then draw 2 more arcs, we would see that they reflect onto each other. So however you want to visually confirm it is fine, but really just know that after that reflection, those 2 triangles would map onto each other perfectly. So I want you to think back on what we did here. We really took the fact that we knew that these 2 sides in the angle were congruent to these 2 sides in the angle, and we said let's map them onto each other. So we brought the 2 congruent angles together here. After bringing the 2 angles together, we said let's get the sides to overlap. So we closed that angle, closed that gap so that that side overlapped. And then now finally with our reflection across AC, this side up top would map onto this side up top. So we've justified it visually by thinking about our constructions, but going forward, I want you to think, if I know that if I know that two sides and the angle between them are congruent in both triangles, that's enough for you to know that those triangles are the same size. So you don't have to go through all this process of justifying it. Now that we justified it here, you can say, going forward, this will apply to any triangle. So if we go on to the back side, I want to write the transformations to correctly notate the congruence or the composition. So basically rewrite all the stuff we just did. So we had said that F, our first transformation, was the translation, right? So we had said first we're going to translate using the vector A prime to A. So my transformation F was the translation of A prime to A, and that was a vector. And I did that to triangle A prime, B prime, C prime. Right? Then after that, we're just going to name our transformation. So this transformation, I'm just going to call it F. After that, G, my transformation G, was really when I did that closing of the gap. So if I think back on this previous slide, I was closing this gap, and by doing that, I was really doing this transformation. So the rotation of CA, C double prime. So the rotation of angle CA, C double prime. And then again, I did that to triangle A, B double prime, C double prime. And I got this from the front side of our notes, so you can flip over to see it again. And then finally, the last thing I did, H is what I'm going to call it. So the last thing I did was that reflection. And so for reflection, we use a lowercase r. We did a reflection across the line AC. Let me draw that a little bit better. AC. And so we did that reflection of the triangle A, B triple prime C. And again, this was on the front side of our notes. So A, B triple prime C is really what I did here. So finally, if I'm bringing this all together, I can say that I have done the following. So I have done function F, or my transformation F, to our triangle A prime. So let me draw a triangle in there. I'll leave some space. A prime, B prime, C prime. So that was the initial image that I started with. So I did the first transformation. So instead of writing all of this, I'm going to say I did F to this triangle. So F is the translation. Then after I did that, so this is really the blue part. After I did that, the new shape that I got from that is what I used to do function G. So now I can say that G was really all of this. G was done to all of the blue stuff. So G is my new transformation. And that transformation was my rotation. So I did the rotation to all of this stuff in here, right? And then finally, I did my transformation H. I don't know why that's green, sorry. I did my transformation H to all the stuff from earlier, right? To whatever I got from G. So H is my final transformation. H contains all the stuff that I had done before. So again, it's building on itself. And so this is a shorter way to write all of this stuff because now I'm just saying F instead of the translation. I'm saying G instead of the rotation, and I'm saying H instead of the reflection. This is this is known as function notation. So this is kind of a sneak peek at Algebra 2 because you'll be doing function notation in Algebra 2, but you'll be doing it with functions, right? So you'll be doing compositions of functions instead of composition of transformations. So for example, in algebra 2, what it would look like is you might get an f of x function. So it's a function that depends on x. And I don't know why that's not writing well for me. Okay. And let's say your function was x plus 7. And say you got a function g of x, and that, again, I don't know why that's not writing. Okay, so say you got a function g, and that g was 2x plus 3. I don't know. So you might end up with a question that says, what is the composition f of g of x? What does that equal, right? So in that case, it's saying take this g of x and plug it into f. So you would take this g of x and you'd plug it into f, but you plug it in specifically anywhere you see an x. So that this composition of the functions would end up being 2x plus 3, because you're plugging this into the place of the x, but you still have the plus 7 left over. So when you do this composition and then you simplify it, you end up with 2x plus 10, for example. So a composition of functions next year will be plugging a function into a function and then simplifying it. So just a heads up, but that's really the same notation we used here. We said f of g, this is h of g of f, right? So again, a composition. If that didn't make a whole lot of sense to you, don't freak out about it. You will see it again next year in Algebra 2, but I just wanted to give you a sneak peek of it today. So going on, now we're going to look at identifying SAS. So we know what SAS criteria is. Again, the two sides that are mentioned have the angle that is also mentioned or labeled. So we're going to see if SAS works in this scenario. So let me have you write SAS on your paper, and then we'll also write that for the next problem. So I'm going to copy that and write it down here. So looking at this picture, it says given angle LNM is equal to LNO, and you see both of those labeled. You also see, let me delete that. You also see that MN and ON are the same length. So MN has a side labeled, ON has a side labeled. So I want to see if they meet SAS criteria. So I can say that the first angle that is mentioned, or the first side that is mentioned, is the fact that MN equals ON. And so if you have your highlighters, it might be worth highlighting this. Is this side corresponds to this side over here. The next thing I would look at is the next side. So I typically look at the sides first. So if I were to look to see if these two triangles have any other side in common, I can see, well, they do. They share this side. So LN on one triangle is the same length as the LN of this other triangle. So that would be what I type here, or write here. LN is equal to LN. Remember, when you're using this in a proof, which we will be doing on our assignment, anytime something equals itself, that is known as the reflexive property. So don't forget that. So LN from one triangle equals LN from the other triangle. And then again, I highlighted that in green. So if you're color coding like I am, you can do that. And then finally, we notice that they have an angle in common. And so what I want to look for is that, are these angles the angles that are formed by these two sides? So angle LNM, L to N to M, is this angle here. And it is formed by the two sides that I highlighted on that triangle. So that's good. L, N, M, sorry, again for my handwriting. And then that is equal to LNO, and L to N to O is this other side. Again, notice it's formed by the two angles that I highlighted. So in this case, since I do have side, angle, side, side, angle side, I would say, yes, this does meet SAS criteria. So that's all you're looking for on your assignment is, does it meet SAS criteria? Do those match up? In this case, yes. So this would be enough for me to say that these two triangles are congruent to each other. You'll see that in our proof coming up. So the next one, I want to do a similar thing. I want to see if these two triangles meet SAS criteria. So I'm looking at HGI. So H to G to I is this top triangle, and then JIG is this bottom one, J to I to G, so this little triangle here. So comparing those two, I can clearly see that HG and IJ, they have in common. So HG is this one, IJ is this one, and they both have a mark through them. So that's my first side. Those are equal. Next, again, I look at if they have another side in common. So they do happen to share this side. They're overlapping on that side. So I would say that the GI or the IG from one triangle is the same as the IG from the other triangle. So we can say IG, GI, it doesn't matter. So that would be another reflexive property if you were writing a proof. So anytime they're overlapping, I would say keep in mind that's going to be reflexive. So they have that side in common. And then finally, the angle that I check for, I want to make sure the angle is between those two sides. So angle HGI, so from H to G to I is this angle here. And that one is between the two sides. So HGI. And that one is equal to the measure of angle JIG. So from J to I to G is this one, and that one is between the two sides that are labeled. And so since those two angles are between the sides that are labeled, I would say yes again for this one. So do they meet SAS? Yes. Finally, we're going to write a proof for this one. I think I can type this one out instead of struggling to write, so let's see. So given our triangle RST is isosceles with RS being equal to RT and SY equaling TZ. So first, remember we always start with the given information, so I'm going to type out that RST is isosceles, RS is equal to RT, and SY is equal to TZ. So take a minute to jot that down. And then our reason, of course, is that it was given to us. And then I'm going to draw my line here. I don't know why I cannot draw a triangle. Okay, anyway, triangle RST. Whew. Next, I would say use this given information to label your diagram. I would also recommend trying to see, well, which triangles am I focusing my attention on? So if I'm trying to prove that RSY and RTZ are congruent, it might help to highlight those. So I could say that RSY is this triangle here, and RTZ is R to T to Z, so this triangle here. Trying to justify that those are congruent. So knowing that RS and RT are equal, I can put a line through RS, I can put a line through RT. I also know that SY and TZ are equal, so in SY I'm going to put 2 lines, in TZ I'm going to put 2 lines. So in those 2 yellow triangles, I've almost got SAS. I've got 2 sides, but now I need some angles to be labeled. So my next thing would be, how can I utilize this information? Because I already labeled both of those in here. But the fact that RST is isosceles tells me something else. So remember that isosceles triangles have 2 equal sides, which we've already labeled. It might help to highlight RST, sorry. So RST is this big triangle. So this big triangle is isosceles. We did already identify the 2 equal sides there. But isosceles triangles also have equal base angles. And so in this case, knowing that this is isosceles should tell me that this angle down at the bottom is congruent to this angle down here, because those are my 2 base angles. They're the 2 angles that are across from the 2 congruent sides, right? So my next thing I'm going to write is that angle RSY is equal to RTZ. And I still have to write like the measure of the angle. So measure of the angle RSY is equal to the measure of the angle RTZ. And the reason I would give for that is base angles of isosceles triangles are equal in measure. So knowing that that was isosceles really helped me out because I found those two angles. Now if I focus my attention on this triangle, I have the two sides and the angle between them labeled. I also have those same two sides and the same angle labeled here. So I can now just jump to the fact that those two triangles are congruent. So now I can say that RSY, I think there's a congruent symbol in here that I can use. Yes. RSY is congruent to triangle RTZ. And then remember I have to say that they're triangles that I'm talking about. So those two triangles are congruent. My reason is going to be because of SAS congruence. They meet the SAS congruence criteria. So that's what you'll be doing for the last two problems on your assignment. You'll be writing proofs similar to this, really just trying to figure out if the two triangles that I named meet SAS. And they will meet SAS because that's what this assignment is all about, is getting practice with SAS. So see if you can try your best to get that done. I did leave an answer key with a sub, so if you have questions, you can ask him to check it for you or ask for some guidance, but he does have that. And then for the first 8 problems, let me see, first 5 problems on your homework assignment are just like this, where you're identifying the side, the angle, and the side, and then making sure that the angle is the one that's formed by the two sides that you labeled. So colors are really super helpful for this. If you don't use colors though, I do at least expect you to put the little tick marks in there and the little angle symbols so that I know that you were labeling your diagram and you can visually see the SAS. So either way, don't just fill this out, fill in the diagram as well. So hopefully that made some sense to you guys. I will be back on Friday, so I'm actually out Wednesday and Thursday. So if you have any questions, they'll have to wait till Friday or until Monday when I see some of you guys on Monday. So yeah, remember that you can rewatch this online if you need to. Otherwise, go ahead and get started on your assignment, and I hope you have a great rest of your day. Bye.